Hey everyone, in this video we're going to go through volume problems using the disk and washer method step by step. And one thing you'll notice right away is that these problems are not all set up the same way. That was done on purpose. The reason is to show that with volumes of revolution, the hardest part usually is not the integration itself. It's recognizing what the radius is, whether there's a hole or not, and whether the variable makes the setup easier. So as we go, keep focusing on the structure of each problem. Are we using disks? Are we using washers? So let's just go problem by problem. So this first problem says find the volume of the solid formed by revolving the region under y equals x squared from x equals 0 to x equals 2 about the x-axis. So let's start with the most basic kind of volume problem. We're revolving the region around under y equals x squared around the x-axis. Since the region goes all the way down to the axis of rotation, there is no hole in the middle. That means that we use a disk method. The disk formula is shown on the top right. So here the radius is just a distance from the curve to the x-axis. So that would just be x squared. So now let's plug that into the formula. We get v equals pi times the integral from 0 to 2 of x squared to the power of 2 dx. Which just becomes v equals pi times the integral from 0 to 2 of x to the power 4 dx. Now let's integrate. Once we integrate, we get x to the power 5 over 5 from 0 to 2, which then you'll just get pi times 32 over 5. And this is a very simple start. We're just squaring the radius and integrating. Let's move on to problem 2. We're going to find the volume of the solid formed by revolving the region under y equals square root of x from x equals 0 to x equals 9 about the x-axis. This is another disk method problem. We're revolving around the x-axis, and again the region touches the axis, so there's no inner radius. That means that the volume equals pi times the integral of 0 to 9 square root of x squared dx. And the square root of x squared just simplifies to x. So volume equals pi times the integral of 0 to 9 x dx. And once we integrate, we get x squared over 2 from 0 to 9. And the final answer, you should get 81 pi over 2. This is a nice reminder that sometimes the algebra actually gets simpler after you square the radius. Next one, we're going to find the volume of a solid formed by revolving the region bounded by y equals x plus 1 and y equals 0. From x equals 0 to x equals 3 about the x-axis. So it's the same axis of revolution, but now the function is linear. We still have a region going from the curve down to the x-axis, so this is still the disk method. The formula is v equals pi times the integral from 0 to 3 x plus 1 squared dx, which just becomes pi times the integral from 0 to 3 of x squared plus 2x plus 1 dx. And now we just integrate term by term, which was the last video, so we get x to the power of 3 over 3 plus x squared plus x from 0 to 3. So once we plug in 3, we just get 21. Show you the math right now. And so the final answer for the volume is 21 pi. This problem is good because it shows that even when the radius looks simple, you still need to square it carefully. Next, we're going to find the volume of the solid formed by revolving the region bounded by x squared plus 1 and y equals 1 from x equals 0 to x equals 2 about the x-axis. Now we switch to washers. Why? Because the region is between two curves, and when we revolve it around the x-axis, there's a gap in the middle. So the washer formula is shown on the top right. And here the outer radius is a distance from the x-axis to the top of the curve, which is y equals x squared plus 1. The inner radius is a distance from the x-axis to the bottom curve, which is y equals 1. So once we plug it into the formula, we get the volume is equal to the pi times the integral from 0 to 2 of x squared plus 1 squared minus 1 squared dx. So we can expand the x squared plus 1 squared, which will get x to the power 4 plus 2x squared plus 1 minus 1. And so the integrand becomes x to the power 4 plus 2x squared. Now that we have that, we're going to integrate it, and we get x to the power 5 over 5 plus 2x to the power of 3 all over 3. And we're going to evaluate it from 0 to 2, which we'll get 32 over 5 plus 16 over 3. And we can get a common denominator of 15, which will lead us to get 176 over 15 times pi. So this is kind of like the key washer idea. It's the outer area minus the inner area. Next, we're going to find the volume of the solid formed by revolving the region bounded by y equals 4 and y equals x squared from x equals negative 2 to x equals 2 about the x-axis. So this is another washer problem. The region is between the horizontal line y equals 4 and the parabola y equals x squared, and we revolve it around the x-axis. So the outer radius is 4, inner radius is x squared, and that we just get pi times the integral from negative 2 to 2 times, 4 squared minus x squared squared dx. Which will just get pi times integral 16 minus x to the power 4 dx. Now we integrate it, and we get 16x minus x to the power 5 over 5. And we're going to evaluate that from negative 2 to 2. And so once we evaluate it at 2, we get 128 over 5. And we evaluate it at negative 2, we get negative 128 over 5. And we're just left with 256 over 5. So the final volume is 256 pi all over 5. And this one is nice because it also reminds you to be careful with those negative lower bounds. So for this next problem, we're going to find the volume of the solid formed by revolving the region bounded by x equals y squared and x equals 4 about the y-axis. So now we're changing the orientation. The region is given in terms of x and y, and we're revolving around the y-axis. Since the boundaries are more naturally written as x values, it makes sense to integrate with respect to y. We should also find the y limits. So, since x equals 4 and x equals y squared, set them equal. And we're going to get y equals negative 2 to y equals 2. So now because the region goes from x equals y squared out to x equals 4, when rotated around the y-axis, we get washers. The outer radius is the distance from the y-axis to x equals 4, so ry equals 4, capital R. And the inner radius is the distance from the y-axis to x equals y squared, so lowercase ry equals y squared. So now we set up the integral. Volume equals pi times integral from negative 2 to 2 of 4 squared minus y squared squared dy. So the volume equals pi times the integral of negative 2 to 2 of 16 minus y to the power 4 dy. Once we integrate it, we get 16y minus y to the power of 5 all over 5. And we evaluate that from negative 2 to 2. And this gives the same arithmetic as the previous problem, so we're just going to get our final answer as 256 pi over 5. And this is a really important example because it shows that sometimes the main skill is choosing the correct variable. So the next one. Next, we're going to find the volume of a solid formed by revolving the region bounded by y equals 2x and y equals x squared about the x-axis. So just give it a second for you guys to try that. You guys can pause the video. But now, we're going to get started. So this one adds another step. First, we need the intersection points. Set the equations equal to each other. We're going to get everything on one side, so we're going to get x squared minus 2x equals 0. And we're just going to know that x equals 0 and x equals 2. Now we figure out which curve is on top between 0 and 2. So for example, x equals 1, we're going to get y equals x squared equals 1. So y equals 2x is above y equals x squared. Since we're revolving around the x-axis, that means that the outer radius is 2x, and the inner radius is x squared. So we use the same Washer's formula. We get pi times the integral from 0 to 2 of 2x squared minus x squared squared dx. So once we simplify that, we should get the integral of 0 to 2 times pi of 4x squared minus x to the power 4 dx. Once we integrate that, we get 4x cubed over 3 minus x to the power 5 over 5. And we just evaluate that from 0 to 2. So once we plug in 2, we get 32 over 3 minus 32 over 5. Don't forget the pi, by the way. And then we get the common denominator 15, so we're just going to be left with 160 over 15 minus 96 over 15, which is 64 over 15. So our final volume is just going to be 64 pi over 15. So this is a classic AP calculus setup. Find the intersections first, identify the top and the bottom, then use the outer radius minus the inner radius. Next up, we're going to find the volume of the solid formed by revolving the region bounded by x equals y plus 2 and x equals y squared about the y-axis. So for this last one, we'll do a washer problem in terms of y. But first, we need the intersection values. So again, we set them equal to each other. And we're going to go through all the math. So we do y squared minus y minus 2 equals 0. We factor it, still setting it to equal to 0. And we get y equals negative 1 to y equals 2. Now we decide which graph is farther to the right, because that will be the outer radius from the y-axis. So a good way to think of it is like right minus left. So let's try y equals 0. So once we plug in y equals 0, we find out that x equals y squared, which is equal to 0. So x equals y plus 2 is the outer curve. That means that the outer radius is y plus 2. And the inner radius is y squared. So we can plug this into the washer formula. So we get pi times the integral from negative 1 to 2 of y plus 2 squared minus y squared squared dy. And if we expand that, we get y squared plus 4y plus 4. And we write this from pi times the integral from negative 1 to 2 of, if we write it in the correct order, negative y to the power of 4 plus y squared plus 4y plus 4 dy. And we integrate this term by term. So we're going to be left with negative y to the power of 5 over 5 plus y cubed over 3 plus 2y squared plus 4y, and then we evaluate that from -1 to 2. Now we can evaluate this carefully. So at y equals 2, we're going to be left with -32 over 5 plus 8 over 3 plus 8 plus 8. And then we evaluate at y equals -1, and we're going to get 1 over 5 minus 1 over 3 plus 2 minus 4. So this is just going to be basic arithmetic, and we're going to get 1 over 5 minus 1 over 3 minus 2. And now subtracting the lower value from the upper value gives 72 over 5. So the final value is 72 pi over 5. This question is a great example because it combines intersection points, outer versus inner radius, and integrating with respect to y. So, overall, the big idea in all these problems is this. For volume by disk and washers, everything comes down to understanding the radii. If there is no hole, use disks. If there is a hole, use washers. And then from there, the real job is identifying the axis of rotation, the outer radius, the inner radius, and the correct limits of integration. Once you set up correctly, the rest is a step-by-step integration. So even if a problem looks complicated, don't try to do everything at once. Thank you for listening, and see you at the next video.